So the problem name is search in rotated sorted array. So we will be given a rotated sorted array and a target. We need to search this target in this rotated sorted array, and we need to return the index that we uh, index of the target that we found in this array. This is like a searching problem. So we can use brute force solution like a linear search. Using linear search, you can search this target with a time complexity of O of n, and space complexity will be O of 1. But in this problem, you need to solve this using O of log n runtime complexity. So for that, we need to use binary search, because binary search can make this binary search can be solved in O of log n time complexity, right? So we'll be using binary search. I'll be explaining example 1. So this is for rotate array logic. So what will be so this is the given array, and the target we have given is, in the example 1, 0. Answer will be, answer is 4. Is we found the target 0 here. So let me show you how this approach will be using binary search. So what we do in a binary search, we calculate the midpoint and check if it is equal to the target. If it is not, we need to either move to left side, or else we need to move to right side based on the target we have. In a binary search, the elements are in increasing order, but here the elements are some elements are in increasing, and remaining elements are in remaining elements are also in increasing, but first elements will be larger than the last part elements. Here we can see 4, 5, 6, 7 are larger elements than this side elements. So since this is a rotated sorted array, so we need to in the main problem here is, we need to know the in which direction we need to move, like for moving in which direction the low should be moved, or in which direction the high no in which in which side of direction we need to move is the main problem here. Why? Because this is in rotated sorted array. So first I will calculate the mid for this. It will be 0 plus 6 divided by 2. It will be 3. So first we have found the mid at this part, and the target is, we have 0. We need to check whether a of array of low is 4, right? Is 4 less than or is equal to a of mid. If this is satisfying, then what we can say, we can search in left, we need to check whether 0 is lying in this range. Means uh, we need to check if target is greater than or is equal to array of low, and target is less than or is equal to a of mid. If this is the case, what we know, here we have mid, right? Here we have low, and here high. If we found the target in this range, what we can say, we will be moving high is equal to mid minus 1. So this, in this way, we will be reducing this side part. We'll reduce the searching in this part, because if the target is lying in this range, why we need to move, why we need to check other part. So in the binary search also, we'll be moving, we'll be skipping the half of the array, and we'll be moving towards the left. So in this way, we move high is equal to mid minus 1. Else is the case, if even though this condition is satisfied, a of low is less than or is equal to a of mid, and target is not lying here. Here we can see 4 is less than or is equal to 7, and the target is not lying here, it is lying towards the right side part. So we need to move, in that case, low is equal to mid plus 1. In that case only we move, because target is lying towards the right side point. So this will be one case. Next case will be, I will copy this. So now if now target is 0, so now we know that target is lying towards the right, even though the 4 is less than or is equal to 7, and we checked that target is lying in this in this elements or not. So it is not lying in these elements, so we move to right. So now the low will be pointing to the mid plus 1, which is previously mid is 3, now the mid will become 4, and high is become previously is 6. Now again we calculate mid. Since low is less than or is equal to high, we'll calculate mid. 4 plus 6 divided by 2, which is 4 plus 6 10 divided by 2, which is 5. Now the new mid will become 5, and here the low is there, and here the high is there, and we'll be again checking whether 0 is less than or a of low, a of low is less than or is equal to a of high, a of mid. If this is the case, then we can search in the left part, we can search in left range, like since 0 is less than or is equal to 1, so we can check whether this 0 is existing in this part. So is target, if target is greater than or is equal to a of low, and target is greater than or is less than or is equal to a of mid. If target is in this range, then we can definitely say that we can move high is equal to mid minus 1. We can found in this part, right? So high will be moving to the left side. Else is the case, if the target is not lying in this range, in this left range, then we simply move low is equal to mid plus 1, because searching here is a waste of time. So we search in the right side part. So in that case, in the else part, low is equal to mid plus 1 will be returning. So as I said, this is the previous case, and now uh, new case new case will be, if the target is new case will be, suppose if the a of low is not less than or is equal to a of mid, it is greater than a of mid. What if the area of flow is greater than a of mid? For suppose or suppose here, if the mid is here, suppose let us think it like that, and the area of low is suppose low is at here and high is at somewhere here, uh, like somewhere here, and let us think that mid is one, index 5. Let us think sometime for understanding the other case where the mid is less than the area of low, means we need to check in the right side part, since it can be known that in the right side part the elements are in sorted manner. Elements are in sorted way, like if we have 1 2 3 4 5 6, in this way, if the elements are there, we can know that the this side part elements will be always be in sorted manner. So we can check in the right side part, if a target is greater than or is equal to a of mid, we can check it like this, a of mid is less than or is equal to target is less than or is equal to a of I. You can check like this. So if the target is lying towards the right, in this case, when the area of low is greater than area of mid, we don't, if it is lying in the right side, then we simply what we'll do, we'll make low is equal to mid plus 1. Even though we checked in the right side, this is in sorted way, towards the right side, this will be in sorted, this side will be sorted. Even though we checked this side, sometimes the target will be here, somewhere here. Suppose the target is 7, so we checked in the right side part, it is not there in the right side part, then we need to move to the left side. I will be moved to the left side part. So in this way, we can make the decision of either moving to the left side or moving to the right side will be based on will be decided using these two if statements. When the area of low is less than or is equal to area of mid, when the area of low is less than or is equal to area of mid, we will checking the target in the left in this range. Because these are in a sorted manner, in this range we can check. If the target is found in this range, we simply move high is equal to mid minus 1, because we can know the target is lying in this range. Suppose even though this is in sorted order and we checked our target in this range, if it is not lying in this range, definitely this will be on the somewhere right side, so we will move low is equal to mid plus 1 in that case. Next, here another case will be if a of low is greater than a of mid. Here suppose this is the mid, a of low is greater than mid, this is not in a sorted order, so we check the sort where will be the sorted order, then sorted order will be towards the right side, definitely the sorted order will be towards the right side, so we check whether the target is lying in this range. Since if the target is lying in this range, we move low is equal to mid plus 1. We skip this entire left part and we will be searching in this range to search the target. Suppose if the target is not lying in this right side part also, we will be moving to the left side part, high is equal to mid minus 1. So the target may be lying in this range, so we will be moving high is equal to mid minus 1. In this way we are going to solve this. So here the code is not fully written. Here we have taken the size of the array as n, and we took the low as 0 and high as last element, which is 6. Here the last element is last index is 6 n minus 1, and we continue our searching when till low less than or is equal to high. If there is only one element, low will be low and high will be pointing to the same element, right? So that's why we need to search till low is less than or is equal to high, and we will be calculating the mid using low plus high minus low divided by 2. And if the target is equal to the mid value, we directly return the middle value. And for moving either to left or to the right will be based upon the two if statements. if uh, uh, if nums of low is less than or is equal to nums of mid, and this is the case where left part is completely sorted from a of low, nums of low to nums of mid. So we will be checking if target is lying in this range. If nums of low is less than or is equal to target, and nums and target is less than or is equal to nums of mid. If this is the case, then what we do, we make high is equal to mid minus 1, else low is equal to mid plus 1. So we move to the left when this is satisfying. That left in the left side part, we found the target lying in this left side, so high is equal to mid minus 1. If it is not lying in this left side, we'll be moving to the right side. Next, if nums of low is greater than nums of mid, this is the else part, right, for this condition. So instead of using if, I will directly use else, and this is indicating else is indicating that nums of low is greater than nums of mid. Then we can definitely say that the right side of mid will be definitely sorted. From mid, the right side part is sorted. So we will be checking whether nums of mid is less than or is equal to target, whether we check in the right side part whether target is lying towards the right side part of the mid, and nums of up to high we will be checking. If it is lying in this range, what will we do, we make low is equal to mid plus 1. Else is the case where even though we searched in the right side part, right side sorted array, and we don't find the target is lying on that side, then we make move to the left side. So in this way, the movement will be decided either to move left side or right side. And when the target is found, we will be returning the mid. If there is no any target found, we will be returning -1 when low is crossed the high. Let me run this. This is working for the given test example 1. I will work with the entire examples. So this is also working with the given examples. I will submit. So we can see that this is working. The time complexity will be O of log n, as here we have asked to solve this in O of log n. We have solved this using binary search, and this time complexity is O of log n. And space complexity, we have not used any space complexity, so the space complexity will be O of 1. Here we don't use any space complexity. Okay, time complexity will be O of log n, and space complexity will be O of 1.